Hello, so today we are going to do problems from biweekly contest 118. So the second problem is maximize areas of square hole in a grid. This one description is very difficult to understand, so I'm going to try to simplify it a little bit. But basically we get two values, n and m, right? And these basically represent the horizontal bars in the middle, right? So basically, let's say for example here, this tells us there is one vertical bar, and so that's why we have n equal to 1, and then one horizontal, so that's why we have equal to 1. If we take a look at this one, we have 1, 2, 3 horizontal one, so that's m equal to 3. So m is for vertical and then n is for horizontal. And so we have two horizontal ones, so that's why we have two here. And so if you look at it this way with the bars in the middle, so that means basically what's the length of this matrix, or of this rectangle, if you call it so. Then, so if the middle ones are here, we have 3, then we need to add 1 for the beginning and 1 for the end. So it's m plus 2. So that's what they are saying essentially here, is that we have m plus 2 bars because the first one and the second one are not middle ones, so they are not counted in m. Same thing for horizontal bars. We add 2 for the beginning and the end. Okay, and the bars are indexed starting from 1, so that's what we have here. So that's the first part that is slightly confusing. The second part is we have two arrays, h bars and v bars. And these also are just for the middle bars, okay? So what this means is that here, for example, h bars we have 2 and 3. That means this bar and this bar. So it's not for the actual content of the column, it's just for the bar itself, okay? So that's one thing to understand here. So we have these two arrays that contain some bars, and so since these bars are only for the interior, okay, that it tells you that it starts from 2. It doesn't start from the beginning. It starts from the 2 to the end. And the operation we are allowed to do here is remove bars that satisfy any of these conditions. If it's a horizontal bar, we can remove it only if it's in h bars array. If it's a vertical bar, we can remove it only if it's in v bars array. Okay, and the goal of the problem is to return the maximum area of a square shaped hole that we can get after removing the bars. So basically, what's the maximum area we can get by removing some bars? We can remove as many as we can as long as they are in this condition. Basically, for horizontal in h bar, for vertical in v bar. So that's the problem. I think the key insight to understand the problem is to start thinking about the bars here instead of thinking about the content. Because if you remove a bar, right, then now this becomes a larger hole, right? Okay, that's the core idea. Okay, so let's look at the examples. So for the first example, well, we can remove bar 2, so we can remove this one. And for we can remove also, sorry, this is vertical. So vertical we can remove only 2. For horizontal we can remove 2. And 3, right? Okay, and so what's the maximum square shaped hole we can get? Well, the maximum we can get is this, right? Okay, so that we get 4. If we look here at this one here, well, we can remove the h bar here, we can remove the v bar here, and so the maximum is this entire thing. Okay. So just to go back to this one thing I realized you may have missed is, why do we remove just this one? Why not remove this one? Well, if we remove this one, then the problem becomes that if we remove 3, the h bar 3, since we are allowed to do it, since it's in h bar, then we'll get this entire thing as the whole. But this entire thing is 4 by 3, so it's not a square, okay? So this is something you need to pay attention to. It's not a square, so we can't do that. The maximum square we can get is actually just this one, by just removing the bar, horizontal bar 2 and vertical bar 2. So if we do that, then we get 2 by 2, So that works. Sorry, this one, if you want to get the length, it's 3 by 2, and so it's a rectangle. But the square, we can only get this one. Okay, I wanted to clarify that. So that's the problem. Now, if we look at the constraint, the number of bars can be really big. The H bars themselves and V bars are small, and they are distinct. So how can we tackle this? Okay, so how do we tackle this? Well, if you take a look here at this example, we can take a larger one, so it's easier to see. So n equal to 2, that means basically we have 4, 2, 3, we have 4 horizontal, and then m equal to 3, we have 5 vertical. So here we can take out number 2, so we can take out this bar here. Sorry, this is horizontal, we can take this one, we can take this one, and then vertical, we can take this one, and this one. Okay? So what does this mean? If we take all of them, then we get how much? 1, 2, 3. So we get essentially 3 by 1, 2, 3, 4, 4. If I'm just taking the length here, then that would be not a rectangle, not a square, that's a rectangle. So we can't actually take all of them. So let's not take 4. Let's not take vertical bar 4, for example. So let's not take vertical bar 4. In that case, what's the area that we get? Well, in that case, what we are going to get is this one. Okay, so 3 by 3, so 9, so that works, so 9. The other option is, let's not take bar 2, and so if we don't do that, then we would get this area, which is also 3 by 3. So we'll get actually this area, which is 3 by 3, so still 9. So the best we can do is 9. Okay, so what can we extract from this? So the first thing to notice is that all that matters actually is the consecutive bars, right? Because if you have, let's say, if you had here, let's say you had 2, 4, right? Then you can't take both because that won't give you a whole, right? You can only take this one, and so that will give you a square like this, right? Or you could take the 4 here and that will give you the square like this, but you can't have 2 and 4 together in a whole because there is 3 that is not there. So what matters basically is consecutive bars. And this is valid for both horizontal and vertical because same thing, if let's say we had only 2, we didn't have 3, then we can only take this one, this one, right? So we can take only this area here. If we had only maybe 3, then that means we can take only this area, but we can't take a whole that removes both 2 and 3. So we can't have a larger area. But even in this case, for example, remember, we can take only a square, so that means we can take only this. We can't take the entire thing. Same thing with the previous one, we can take only this entire thing. So again, for vertical bars, horizontal bars, what matters is consecutive bars. Okay, so to maximize the whole we can get, what this means is basically we want to get the longest streak of bars for both horizontal and vertical. Okay, and so how do we do that then? So that's the main question, is to get the maximum hole or the maximum gap, we need to get the maximum streak. In this case, the maximum streak is 2 to 3 and 2 to 3. If we had something like maybe H horizontal bars are like 2, 3, 4, 5, maybe 6, 9. And then for the vertical bars, let's say it was 2, 3, 4, 5, and then 10, 12. Then the maximum streak is here, and the maximum streak for this one is here. But remember, we want a square, right? So that means we can actually take only, to get a square, we need the same number of bars in both. So we can only take this and this. We can't take this 6 here. Okay? if we had maybe didn't have 2 and had 6 here, then the maximum one we can take is going to be 3 up to 6 and 3 up to 6. So basically what this tells you is that we need to first find the longest streak for both, but once we find it, because one may be longer and we need a square, we need to find we need to take the minimum of the two, okay? So we can just find the maximum streak for both, take the minimum of the two, because that would mean we will get a square, and then just get the square of that. So in this case, for example, with the 3 here, we have each of them has, so this one has streak of 5, this one has streak of 4. So take the minimum, 4 by 4, that's 16, and that's actually going to be the area we get, because if you look at it, it's going to be includes 3, it includes column 3, column 4, column 5, and column 6. So and includes row 3, row 4, row 5, row 6, because we'll remove the bars. And so that would mean 4 by 4, so that's 16, right? And that's sort of pretty much it. That's the idea. We will just, to find the consecutive one, we will just check the difference between each element and the next. Now, one thing to note here is that we are not guaranteed that the bars are sorted. We could get, for example, for this HB, we could get it like this, 3, 9, 5, 6, 4, something like this. And maybe 2 here. And so it would be hard to check if it's the streak of consecutive, because then this one, the difference is not 1, but we need to check it against 4, so we need to sort first. And this should be quick, because we are guaranteed that the length of H bar and V bar in the constraint, we are guaranteed that it doesn't exceed, that it's smaller or equal to 100. Okay? So first we will sort the bars, and then we will find the longest streak of each, take the min, and then get the square of that. That would be the maximum area. Okay, so yeah, let's implement this solution and make sure it passes. Okay, so let's implement this. So first we said we need to get the longest streak for each of the bars. So let's have one function to do it for both. So this function, let's call it basically streak for the horizontal bars. So we'll call it with horizontal bars. And then we'll do the same thing to get it for the vertical bars. So this would be V like this. And then we said that we need to find the gap, which is going to be just the minimum of the both, because we are looking for a square. And then we will return gap to the power of 2, right? Okay, so now we need to get the longest streak. Well, first we said that we want to sort the bars, because we are not guaranteed that they are sorted. And then we sort the V bars. And now here, well, to get the best streak, let's call it, we need to keep track of the current streak, right? Let's say each of them is 0 first. And then so the current streak is actually first starts at 1, because we want to compare, right? You can at least get 1, because if you look at the matrix here, you can at least get this one, even if you don't remove any bars. Of course, this is not a square, so you can't do it, but you can at least get 1 by 1, like this one, okay? So what we need to do here is just go through the length of the bars, minus 1, so that because we want to check against the next one, I plus 1, so we want this to work properly. So in this case, we want to check if we have consecutive bars, so we check if the next one and the current one, the difference is 1, because if they are not consecutive, that means we can't continue the current streak, we can't continue the current gap. And so in this case, only if they are equal to 1 that we can increase our current streak. Otherwise, we need to reset streak to 1, because we are starting a new one. But in each of them, we want to check if we have the best streak so far. So we take the max of what we have so far in the current streak. And then at the end, we just want to return the best streak we found. So this is going to be the longest one. And that's pretty much it. So if we run this, Looks like there is one single problem. Let's see. So of course the best streak is 1 since that's the current streak. And let's so one detail here is that this is counting just the bars that we remove, right? So we need to do +1 so that we can get the actual length of the gap. So that's just the problem that we have here. And so, sorry, this one we shouldn't have it. So if I run this and submit, it should pass, and that passes. Okay, so the main things that this problem, that you need to understand for this problem is that you are actually removing the bars, and the fact that you are also, you need a square, so you need the two sides, the gaps for the horizontal and vertical to be equal, and so you need to take the min of the streak for each, between the two, right? So that's the main idea here. Yeah, so that's pretty much it for this solution. This is even again in terms of the bar size, but since the size is small, this is negligible. The longest streak is oven in terms of the bars as well. Yeah, so pretty should be pretty quick here. Yeah, so that's pretty much it. If you liked this explanation and want to get one-on-one coaching, reach out to me via Superpeer. And that's pretty much it. See you on the next one. Bye.